panel discussion today. We have a pretty strong group of panelists today that we want to hear more about their experience as RCD professionals. Today we're going to have Brian is going to lead us through some discussions, ask a few questions, and then as the panel proceeds, people can drop questions into the chat or we will try to adjust them as we go. So the first 5 minutes is us welcoming them. You'll see their lightning talks and introductions for the first 15 minutes, and then we'll have the panel questions and discussion and then a wrap up. So during the panel discussion and questions, if you have questions, please drop them into the chat or raise your hand. Is that, Brian, is that how you prefer to have them, or do you want them just to add them to the chat and we address them later?
Either way, I think Anita's going to help watch for those. So however you're willing to throw a question out is just fine.
Okay.
Yeah. Keep an eye on the chat and the page.
Okay, very good. So with that, do we want to start with the lightning talks?
Sure. But first, we have Robin.
All right. Hello, my name is Robin Migach. I think I'll just go through this slide in chronological order. So I'll start with the left here. I did my bachelor's degree in mechanical engineering at the University of Utah. And I also worked as a technical assistant, which is the part-time role at the University of Utah Center for High Performance Computing. And I worked there throughout my entire undergraduate studies as a member of the user services team. And in that capacity, I worked on some software. I presented a project, the Arbiter tool, which collects usage information on login nodes and restricts access to resources at 2 conferences. And one of them was Best Poster at Rocky Mountain Advanced Computing Consortium. I also worked on training videos and documentation and produced newsletters. And I created and presented for the seminar series a presentation about Git, the version control software. And then finally, I explored some data collection and visualization options. And now I'm a PhD candidate at Brown University in Providence, Rhode Island. And I'm in the final year of my program now. I'm working on fluid mechanics research, both theoretical and numerical. So the numerical part, of course, my experience with HPC is invaluable for that. And also I've published and presented research in this capacity. So my experience with the presentations at CHPC were also super helpful. And finally, I've served as a teaching assistant and taught a summer class for high school students. And so my experience with the user training videos and documentation have been super helpful for that as well. And so I'm expecting to finish up my graduate studies in the spring or summer of 2024. And I'm looking for a career that involves both engineering and technology. So I'm actually leaning more toward the high performance computing side of that, but also with some fluid mechanics or other engineering aspects.
All right, we'll move on to Emerson.
Hi, my name is Emerson Ford. I guess also to go through this chronologically as well. So I started off working on a honors bachelor degree in computer science and a bachelor's degree in mathematics at the University of Utah. During my time there, I also worked as a student intern at the Center for High Performance Computing at the University of Utah. The 2 projects I primarily worked on there was infrastructure as code automation. So this is things like Terraform, Ansible, Foreman, and then on the Slate research project where I was helping out with some of the Kubernetes stuff, new hardware provisioning, and some of the networking pieces. Fortunately, like during that time, the CHPC was allowed me to kind of go off every summer on an internship. And so I ended up interning as a production engineering intern at Meta 3 different summers in 2018, 2019, and 2020. And that has turned into a full-time role where I'm now a production engineer and technical lead for a team of 5 at Meta, specifically on the ZippyDB team, which is our hyperscale distributed key value service. On the team, I work on its security and privacy, its internal resharding service, its access layer, and then a lot of its automation as well. a lot of the like stuff that I ended up getting from my student internship, like at the CHPC, was super invaluable for kind of learning the skills of what it means to be a production engineer and whatnot. So that was a really, really big part of kind of even being able to get the internship to begin with. And then in terms of future plans, honestly, I don't really know. I'm still kind of taking it one step at a time. Currently, I've still been having a lot of fun working at Meta. They've been giving me a lot of opportunity to grow and explore, and there's like no end to the amount of problems like that exist here. But aside from that, like I've been kind of missing the more academic side of things. So I've also been thinking about at some point maybe going back to academia, maybe working in distributed systems research or programming languages research. Not quite sure, but taking it one step at a time.
We'll move on to Matt.
Hey everyone, thanks for having me on this panel. Excited to be here. My name is Matt Selensky. I am currently a computational specialist with Northwestern University's Research Computing and Data Services team. Very recently defended my PhD just back in May of this year. And for about 2.5 years, I was a student research computing consultant on the same team I'm on now. And so just to give some background about where I'm coming from, I did my PhD in microbial ecology research. So I used high throughput DNA sequencing technologies to look at the community structures and potential functions of microbes living in cave systems across North America. So I actually started working on Quest, which is Northwestern's HPC system, through my research, and kind of got to know some of the folks on the team just by doing research. And what I kind of found, spending half a decade doing research and writing papers and writing grants and stuff like this was, my passion didn't necessarily lie there. I would often get in trouble with my committee, spending more time helping my lab mates debug their code and run stuff on the HPC system than actually writing my thesis. So I've definitely found kind of a calling in this sort of work and really enjoy it. The last kind of half of this slide, I'm happy to expand on this in the Q&A section, but I kind of just wanted to briefly summarize sort of a lot of the responsibilities I had as a student consultant and sort of how they have evolved now to my current role as a computational specialist. So as a student consultant, I did a lot of things like responding to support tickets, managing accounts, updating our documentation. And sort of near the end of my experience, I got the opportunity to lead and develop some topic-specific user workshops. So one in particular that I was especially proud of was a Nextflow in HPC, or how to use Nextflow on Quest. And so I still do a lot of that, this sort of work as a computational specialist. Gave me a great foundation for what I currently do. But now I would say the biggest difference is that I am more directly interacting with researchers, more directly consulting with groups and trying to understand what their needs are, meeting them where they're at, and seeing how we can support them, and also collaborating with a lot of other IT groups across campus to kind of make that happen. So thank you all.
On to Aaron.
Yeah. Hi guys. My name is Airan Flores. So I'll go also in chronological order. So I did my bachelor's in computer science in UTEP, University of Texas El Paso. I graduated this May, and I'm also doing my master's in software engineering and starting this semester. So I also I am part of the Cyber Corps new cohort for this year. So basically it's a scholarship for service with the Department of Defense or the government. And that's currently. And this summer I also was a intern for Los Alamos National Laboratory as a high performance computing intern, graduate intern, where I worked with the Cray testbed, building a role-based access, optimizing like roles for basically the admins to use. And I'm also part of the CASI, Computing Alliance of Hispanic Serving Institution organization at my school. And I'm part of the Ally and Prodigy program. So I'm basically a mentor for all the new students in computer science. And mainly it's focused on women in STEM. And also for my future career goals, since I have the new scholarship for service, I have to work for the government 2 years after my graduation, focused in cybersecurity. And since I did my concentration in cybersecurity, my bachelor's, my goal is to basically find my best fit in the cybersecurity world, and also finding which industry is best for me, if either government, academia, or like industry with like company industries. And also like an academic goal is graduate my master's with a 4.0 GPA. And yeah, that's it. Thank you so much.
That kind of hits the end of the slides. Let me go ahead and unshare. So what we'd like to do at this point is to turn things kind of over to some questions, and we have a few prepared that we can use, but we'd love to invite people to add in chat, raise hand or add into the call doc additional questions you'd like to throw in front of the panel. And we'll just rotate through. So to kind of help us get started a little bit, we prepared a few questions, and the first few kind of all start with the same kind of premise. And the premise is, how have your work experiences and skills developed as an RCD part-time student worker? As it relates to, how has it helped you with classes that you're in, or classes you completed, or how did it contribute to improving your academic experience? So it's just kind of which of our panel members would like to maybe field that one first and rotate around. Or I can call on people. Let's go go ahead.
Oh, thank you. I was going to say, I don't know if I can speak to how it helped me with classes, because personally, I was done taking coursework once I started being a student consultant on our team. But one thing that it did really help me with academically was, when you're, I think many of us can relate, when you're in graduate school, you're often so pigeonholed in your particular research topic, both in terms of the technical jargon and sort of what you talk about with your colleagues, but also the networks that you kind of build yourself professionally and personally. And so what the student consultant role for me, how that really helped me was sort of expanding my network, allowing me to learn from a lot of different people from different fields about how to not only facilitate HPC research, but just kind of perform it. And I found it really helped with my presentation skills as well, being able to talk to people of different backgrounds, not just other microbial ecologists about these highly technical topics, but talking to material scientists or economists or whoever like that. I found my experience to be very helpful for that sort of thing.
Thanks. Emerson?
Yeah, I can chat a little bit about, I guess, I mean, I'm not in academia at the moment, so this is just classes I have taken. But the first example that comes to mind, or the strongest example, is when I took a networking class, like during my undergrad. Networking classes can be rather dry in my experience. Feel like all it is oftentimes memorizing just what is the OSI model, kind of stepping through bit by bit. And so at least for me, like when it's like really dry like that, I have a hard time kind of really internalizing the information that I'm learning. But then the nice part of working at the CHPC was as part of my projects, like I kind of had this like test switch that I had available to me. And I discovered firsthand why the spanning tree protocol was created, because I managed to create a bridge loop as I was trying to set things up on my test switch. And if any of you have ever created a bridge loop, it also means that you can't access the management layer of that switch. I guess if you do things right, then you can, but I did not do things right. So as a result, I ended up having to pull Joe in to kind of help me. He had to pull out a good old-fashioned serial cable to actually kind of fix the bridge loop that I had caused. But kind of like seeing the real world examples of that, where you're kind of learning in class about this spanning tree protocol, and you're like, okay, like, what does this mean? And then like actually having like networking hardware to be able to create, like, see why does that exist and what are the sort of problems that those the things that you're learning in class address. So it was really, really cool for me. And I think the networking class was like infinitely more interesting to me because like I was able to get that real world experience of like, okay, I understand what it means to be operating on layer 2 or layer 3 or layer 4, so on and so forth. And then also kind of thinking about it like later on in my bachelor's degree, like when I started taking some grad level classes, we would read a lot of research papers, and I'm particularly interested in like high performance systems. And there's a number of research papers out there kind of related to like high performance networking, like with like RDMA and InfiniBand and so on and so forth. Like one of the most interesting ones I was reading is you can actually measure if you're doing, if you receive a cache hit or a cache miss based on a memory access with RDMA, which you can then use as a side channel for all sorts of other security attacks. And normally like you'd be reading these research papers and you don't have access to the hardware. So you're just like, oh, that's, interesting. Like there's this thing called InfiniBand and, all of that. But when you're working like at the CHPC, like you have that hardware available to you. And I feel like that really helps like kind of go the extra mile in understanding like, what is this paper talking about? Like, can I reproduce the results in this? Like, how meaningful is this? Like when you actually have the hands-on experience with the hardware that the paper is talking about. So in both instances, like that was a really, really big deal for me in ways that like the CHPC really augmented my academic experience.
See if we get one more panel member to respond on this one. Aram,
I can go next.
Go ahead.
Sure. So my experience was actually quite similar, I think, to Dr. Selensky's in that I was not a computer science major in university. I was an engineering major. And I actually started at CHPC right after high school. So I was there my entire undergraduate program. And when I came in, I really did not know much about computers. I was more of a hobbyist. I learned to script in video games, and that was kind of my experience. That was the extent of it, right? But over the course of 4 years, I really learned quite a lot. And looking back at some of my earliest Python scripts versus some of the ones that I wrote toward the end of the program, I can really see quite a big difference. And that did transfer over to my academic experience as well. As engineering students, of course, we have to learn basic programming things. Like most mechanical engineering students would learn things like MATLAB just so they could make plots and things like that. But I think it was really an advantage to have that experience in research computing and to have the exposure to different research topics as well.
Let's jump to another question we have here in chat. Chris was asking, did you participate in any formal, informal mentoring? So during the time as an RCD focused part-time student, Iram, would you be willing to answer that one first?
Yes, so since I started my research, I guess, part-time job in my school, first of all, my mentor was my research professor, and she was my class professor and my mentor in research. And she also provided me a lot of opportunities to attend these conferences, such as Supercomputing International Conference and PERC. So in there was also, in the student program, there was also like mentoring programs. So such as like the Mentoring Prodigy. And there I was mentored by a professor from the University of Mississippi in HPC. So that was something as a formal mentoring. And I guess my peers in my school, other graduate students, and also like the students at the student programs mentor me since they were much older or had much experience in these fields. So yes.
How about any of our other panelists willing to answer this one?
I can go again.
Okay.
So at CHPC, I did have a formal mentor, which was Dr. Anita Rent. And I also had sort of more informal mentoring from Brian Haymore and Joe Breen. We had a very, I would say, structured program especially toward the end of it, insofar as there was a specific student who was in charge of running meetings and making sure everyone was staying on track. But I would say that all of the full-time staff were very helpful, and they always answered all of my questions, had time to sit down with me and chat. And it was really just a great experience to have that community as well.
And I can add my perspective here too. So kind of similarly, we had, as I was a student, we would usually have like weekly one-on-ones with a full-time staff member. And so I met with the same individual, Jana Nugent, for most of my time as a student. And, these weekly meetings would just be like 30-minute sort of updates or tag ups, just seeing where I'm at. Maybe I was working on a project that would help the team at a time. Maybe we would spend that time where I would ask about, potential career paths or opportunities, or discussing new projects, something like that. So the mentorship program that the team I was a part of at the time really focused on was kind of, I think, my perspective now, driving the students to kind of do a lot of kind of forge our own paths, see what our interests are, see how that can fit into the goals of the research computing group. And I found it really helpful because it made me feel very invested in what we were doing, because I felt like I had some skin in the game, because maybe there would be some skills I would want to learn. And it was a very much a two-way kind of street in terms of mentorship.
Great, thanks. So let's move on to another question. Kind of looking at the time, and Emerson, I'm going to pick on you first on this one, but because you brought up a good example in your lightning talk. But as you were an RCD, focused student, how did this affect maybe your ability to discover or be accepted into things like internships, or things kind of in addition to what you had as the role as a part-time student at that point?
Yeah. So I guess to say, like, working at the CHPC kind of kickstarted a lot of my interest in systems to begin with. I think systems is a very daunting field to get in, particularly because, like, how should I say it? Like with machine learning, for example, it's entirely feasible for you to kind of do machine learning training like on your laptop. Like, sure, you're not going to create the best models, right? But like it is accessible to you on your laptop. With a lot of like other fields, like within CS, I think it's like similarly, like a lot of it is very accessible to you, like on the machines that you have. But when it comes to systems, you're kind of talking like on the scale of like, like tens to hundreds to thousands to maybe millions of machines, which is not at all accessible. And as a result, like I think it can often be hard to really understand, like you're sitting in a systems class, you're learning about all sorts of these things, and like really kind of understanding like why this matters or what the applicability of it is. And so kind of like at the CHPC, I was getting a lot of that knowledge, like kind of starting from the ground up. What does it mean? Like, what is a bootloader? What does it mean to kind of provision a hardware from the beginning? What does it mean to set up the networking? How do you automate some of these things? What does it look like to start doing things at scale? And as I started diving into that, like that started interesting me into taking more like systems related classes, which I ended up like really falling in love with. And that also helped a lot. Like, truth be told, I never actually applied for a production engineering role at Meta. Or production engineering internship role. I think I applied for like a software engineering internship, and the recruiter pulled my resume out for production engineering specifically because they saw some of the experiences that I had listed from the Center for High Performance Computing. Because a lot of people, like especially like production engineering, is a lot more systems heavy than a traditional software engineering role is. And a lot of people don't have that sort of experience like during their undergrad for the reasons I mentioned before. So that was a really big help for me in kind of starting to kickstart my interest in the world of systems and actually getting hands-on experience and whatnot. And also like being able to play with the hardware was a really big part of it as well, of like actually being able to see what these things look like in practice and playing around with the actual tools and whatnot. So I guess long-winded way of saying, I think like the CHPC was a huge part in like kind of opening the doors into the world of computer science systems for me.
Thanks. Hiram, do you have any comments on this front?
I think since I was in the research area, just by being involved in the conferences helped me a lot because I have attended a while now, and just like exploring different paths. And in the conferences, I discovered HPC, and I didn't have any experience in school related. Any experience with HPC, neither classes or certifications or anything. So I just started like being involved in conferences, in programs, competitions, etc. And I think just by having because I was in research for 2 years, I guess that experience and my involvement as a volunteer and networking with other of my peers, that led me into my internship with Los Alamos, the networking part and just being involved in the student community.
Thanks. About from either Matt or Robin, one of you want to add in on this as well?
Sure, I can. Oh, you unmuted yourself, so go ahead. You sure?
Yeah, please go ahead.
Okay.
Thank you.
I haven't done any internships, but I think that having that experience with HPC was definitely one of the significant contributing factors to getting into the graduate school of my choice. I would say that my advisor was probably very keen on having a student with some experience in computing, as most of our research is numerical, and not having to train a student on using Slurm or understanding MPI or OpenMP, just at like a surface level, is something that I think is really important in engineering or other science fields. I feel like without having experience at CHPC, my applications would not have been as strong. And that also goes back to the mentoring question, where I had those connections and people who knew me over the course of my undergraduate studies and could vouch for my ability to work in a technical setting. I think that was super helpful for graduate school applications.
Thanks. So let's spin this around, because a number of you have touched on this a little bit, but how about this time and experience that you had as it relates to building kind of a network of contacts, and how that has impacted you at that time, or as you look forward to what's happened since? And whoever would like to go first.
Yeah, I'm happy to talk about that. So I feel like for myself, my experience, as I think I maybe mentioned in the PowerPoint I have just been exposed to so many different types of people, not just on the research computing and data services team, but also just individual researchers at the university across all these different domains. And, when you're building your network, especially at this stage in your career, who knows where some connection might lead to. There have definitely been some cases where, I have collaborated with someone or helped someone with a project as sort of my role as a student. And then there was a time when that professor reached out to my PI at the time and said like, oh, like, Matt helped me with this. Like, if he wants to do a postdoc, like, let me know. That wasn't my, intended path, but it has led to things like that, just being exposed to all these different people. So I've very much valued it for that. Absolutely.
Who's next?
I'll go.
Thanks.
I guess just since we all started like from a bachelor's or even master's degree, we all have these small group projects at our classes, and I think that's not enough, because think of it as you are collaborating with people that are kind of similar with you. They live in the same area, maybe they have the same culture, or well, in my case, because my school is a Hispanic serving institution, So I would say I was not ready. Well, I guess I wasn't exposed to a lot of networking, cultures, people, ideas, etc. So when I started attending conferences and participating in competitions and just talking to a lot of people during my internship, for example, I think that's really valuable because not only you are exposed to a lot of valuable networking like aspects, like new opportunities, but also you have new ideas. You are welcoming new ideas basically for your future work, and I think that's really helpful as well.
Great. But we get one more on this one. Maybe Emerson or Robin.
Sure, I can go again. In my case, I'm still very early career, I'd say. So I'm going to be looking for a position soon, but I haven't really to this point. I will say that there is sort of anecdote that is to me a little bit funny, where I was originally just applying for master's programs, and I'd never known anyone who'd done a PhD before. No one in my family or none of my friends, any of that, had any associations with people who'd done a PhD. And I didn't know that you could go directly from a bachelor's degree to a PhD. And it was through talking with some of the scientific consultants at CHPC that I realized that I could, and they also encouraged me to do so. And I think that really kind of changed the trajectory of my life, and that's part of the reason I'm here now.
Thanks. So it looks like we have a few other questions that were suggested by people. So the first one here was a question kind of setting the stage of, I assign mini coding assignments to our students at University of Chicago, HPC, the RCC group. It says, if you were to be in their position, what programming languages would be helpful in practice? Let's see if I'm capturing all that well. Yeah, so I think the question here, and please, Pedram, help me understand if I'm misrepresenting your question. But what programming languages did you guys find most useful kind of during that time, especially if you were in a situation where you were giving some mini coding assignments that to help out with as that role as an RCD part-time student?
I can start off with this one. The first one I would say is Bash. I would highly encourage even doing like Bash golf, because speaking from experience, you can't really run away from Bash. Like sometimes you just need to run a quick one-liner, and kind of understanding how to write like Bash scripts is really, really helpful in that. Not to say like I think some people in this call might disagree with me, but I would not recommend writing full-fledged scripts in Bash. There are far better languages for doing that now. But still having the knowledge of like how to actually use the shell, how to kind of pipe things together, that sort of thing, is something that I do every single day and is something I have never gotten away from. So that is probably one of the things I'd recommend is starting off with Bash. But getting like moving from kind of the shell scripting side of things, I think it's very dependent on like what you're actually looking to get into. I mean, if you're looking for kind of small scale automation / you're looking into getting in like some of the like numerical analysis side of things, like Python is definitely going to be the winner there. That said, like if you're kind of looking more at the system side of things, or you're looking to build large scale automation, at least speaking from my experience, you want to start looking at languages with a lot stronger typing, which is where like I would highly recommend learning Rust, which is seeing a lot of adoption like across the industry for kind of as a safe systems, large scale programming language. So yeah, it's but beyond Bash, I think is the bare minimum, I would say, of like you will always find Bash to be useful no matter where you go. But then aside from that, the next step is, I think, very context dependent on what you're actually looking to get into.
Thanks. Who else would like to tackle this one?
I would say just like Emerson said, it depends on the context that your project is going to be about. But Python, it's a really I like it a lot. And for example, in my internship, I used it for almost everything. And I also saw that even the system administrators also used it. But for example, right now I'm a teaching assistant, graduate teaching assistant for CS1 students. So they're all freshmen, barely getting to know CS, and we are teaching them Java, which is like, it's a controversial topic in my school that Java should not be taught first thing, and it would be better to taught Python. But I guess Java, since it's an object-oriented programming language, it's really, I think it's really useful for them to get to know what is the structure, how to use them, because then they can go over to C, Python, and other languages, and it may be easier for understanding them in the future. Yes.
Great. How about either Robin or Matt?
Yeah, I would just to add on to what Emerson and Hiram said, I absolutely agree. I think if I had to choose like one language or framework that I could take from my student consulting days, it would be learning Bash and the shell. That was just something I never had experience with before joining that position. And absolutely agree. It's helping me now in my current job. As I'm kind of looking in the future, it is a thing that I'm seeing is, what employers want across all these different fields and domains. So I think, solid Bash foundations, and then maybe like an object-oriented or general purpose programming language like Python or even R sometimes, depending on what the application is, I think could be very helpful. But yeah, big Bash fan for sure.
Thanks. We can acknowledge the seashell for the seashell people too. So there's another nice question here I see that's being kind of contributed. So either suppose new students, that based on your experiences, are accepted to work in an HPC center but have nearly zero knowledge about HPC. What are your suggestions on how to bootstrap such a student? And kind of maybe then touch into what the key things skill-wise, topic-wise, will help have that onboarding successful. Who would like to take this one first?
So how can we help? So the question is, how can we help a student with nearly no experience in an HPC position?
Right. Imagining there's one. How do you what would you envision to be a successful way to help introduce them to the world of HPC, and kind of where should they focus first?
Yes. So in the technical part, of course, they need to have some type of Linux experience or knowledge. There's a lot of certifications or trainings with that. Command line is one, shell scripting is one, but also, for example, in my internship, I did not have as much experience. And I remember my mentor saying me all these terms about HPC. He was like, "You're familiar with it, right?" And I'm like, I just stayed quiet, honestly. And he basically said, just do your research and go on, But I think what helped me being successful in my internship is by just looking at them working. For example, I worked in the platform team with assist admins. So they will do a lot of commands and I would ask why, how is this important? I will ask all these questions behind these commands that they used. What are you looking at it specifically in a table? How is looking at a specific data going to help you to move forward to your to resolve your problem, right? And that, and just listening at their conversations, because all of the terms are constantly moving forward, no? And just by listening to them constantly, you kind of understand the context and the background from it. So just the Linux experience, programming language, but also being in contact with your mentor and understanding why they're doing their work and how.
How about Robin?
So I think that response is great. I would definitely agree. When I first started in my role as a technical assistant, I really had no clue what anyone was talking about. There were acronyms being thrown around left and right, and just technical topics that I never even heard of before. And then by the end of the program, when I would sit in on the weekly meetings that the group had, I would understand pretty much everything. And it was really, I would say, stark transition. And I think that students are naturally curious and they'll just pick things up through osmosis if they're inclined to do so and if they have an environment where that's encouraged. I would say that having that experience with Linux is very helpful, and having some programming language experience. Bash is a good option, of course, for scripting. Maybe Python would be really helpful for new students.
About between Emerson and Matt, does one of you want to add a little bit to this?
Yeah, I can jump in here. I don't know. I mean, I might be a little wishy-washy with my answer here, but at least in my experience, what has worked really, really well for me is kind of understanding the why or how things came to be, if that makes sense. For example, like what is the purpose of Ansible, right? Like why did Ansible even come into existence? It was really helpful for me to actually do things by hand, you know, like try to spin up like 5 different machines by hand to have the exact same configuration, that sort of thing, to kind of understand, okay, this is why things like Ansible exist, for example. Also similarly, like, you know, having to actually re-image a host. I think I ended up doing that like 100 times during my time at the CHBC, but starting to understand like what is like a bootloader, what is the installation process like that sort of thing. To help kind of build up like what are these like other tools, like why do they exist, and that has also helped a lot in actually kind of determining like, do we need that sort of thing like in the environment that I'm in? For example, the CHPC, like do we actually need something like Ansible? And understanding the why of like why you're even like why this even came to be in the first place and why you might even be looking at it was immensely helpful for me in kind of like digging into like the specifics of, okay, what are the gotchas you have to be aware of? This is a gotcha I found when we did things manually. Is this gotcha addressed by like automation and that sort of thing? But then it's also really easy to be overwhelmed. Like the world of, you know, Linux and systems is very, very wide. And so you also want to make sure you have a good like starting point for anyone that's new to the space. So I think there's a fine line to be had there. The one bit that I would add there maybe is I've also had a lot of success kind of encouraging other people to do presentations on the things that they have learned like in the system space, because if you're going to be presenting to other people, that really forces you to kind of acknowledge where your knowledge gaps might be, figure out how to word things in a way that not only you understand and can talk about, but other people can understand as well. And so that I have found to be a really great way. For example, like when it comes to containers, like that was a really big thing for me, is I started to understand the basics of containers, like working on the Slate project. And there's of course a lot of nuances. And then like some people at like some of my peers at the CHPC would be like, oh, can you tell me about what a namespace is or what a C group is, you know, that make up this notion of the container abstraction. And as I started doing the presentation, then it became immediate to me, like, what are my knowledge gaps? Like, what are the areas I should dig more into? And then also figuring out ways of digesting the information in a way that other people can understand really helped solidify like my firm understanding of containers as a result. So I don't know if that's, I feel like there, at least for me, there's like no concrete answer, but those are some things that I found to have helped for me at least.
Thanks. So there's another question here, and kind of resonates well with me, because it's something I asked some of the students that have worked with me to get involved in. So the question here is, what activity could help break the loop of feeling bored with repetitious tasks, like account creation, documentation, or I'll ad lib in some things, node wrangling, figuring out which DIM is the dead DIM, you know, and servicing and replacing hard drives, you know, and machines. Talk about the experiences you had that help break this potentially monotonous element that can exist in the various roles you've all held. Who would like to go first on this one?
I'll jump in again, sorry. I can tell you from my experience, like at least at Meta, like no matter where you work, I think you're always gonna have these like very tedious, repetitive like ops tasks is what we call them here, right? My recommendation here is if you're starting to get bored, start building out tooling and automation to do that work for you. Because you can usually kind of reach a place. For example, if you're debugging like which dim is dead, you could start looking into writing a CLI, for example, that you can run that will, look like grok the information that you normally look at as a human to try to determine what the dead dim might be. And then it saves you a bunch of time, down the line when you end up having to do this again. So I don't know, that's been my approach, is to break up that tedium, is start looking at ways that you can automate that job away. And then you'll eventually amass this huge arsenal of tooling to be able to kind of just run them whenever you want to do this tedious debugging for you, or at least get you in a place where you've already kind of looked at the basics of what might be wrong with like a given node or something like that.
Just to kind of have you highlight something here, because you're kind of speaking to what I deal with there. As you described coming up with that solution, was it the fun adventure of finding creative ways to solve a monotonous problem that made the monotonous problem less monotonous?
Yes, like, because you start thinking about all these like kind of gotchas, you start thinking about like you don't realize it, but I think you always have a lot of this background context, right? When you're debugging things or you're like kind of doing these things manually. One, it's really nice to kind of get them out in code in a way that's a form of documentation as well, right? But then two, it makes you kind of think about, oh, what's a clever way of trying to like pull the information you're looking for out in a stable way, for example, and it becomes like a fun little puzzle piece where it makes it less monotonous. I don't know if that's your experience, Brian, but
That's good. That kind of the impression I have. But who else would like to try to tackle this?
I can go. When I was a student at CHBC, I always had multiple projects that I could work on simultaneously. And I think that was really helpful to be able to switch and do something else if I'm really not enjoying something at the moment. And a lot of my projects, since I was affiliated with the user services team, were more user facing or creative in some aspect. Like I would work on training videos. And I think that really helps break the monotony of doing just technical work all day long. And so maybe this goes back to Emerson's point about sharing what you know with other people and maybe doing that in a creative way. So you're not just focused on technical stuff all day, every day.
About Aaron or Matt?
Yeah, I've been kind of reflecting on this. I think that's a really great question. I think for me, I I time box myself a lot for stuff like this. Like if it's something that I find incredibly tedious, and what I'm thinking of that we would do as students would be account management. That is a fairly tedious thing. We have a giant spreadsheet that we cross-reference and stuff, and once you do it once, you do it rote essentially. But it is hard to automate, unfortunately. And I found I would be the most productive and had the most success if I just forced myself to do this for 20 minutes. And then at the end of the 20 minutes, I would almost reward myself with a more cerebral project, because I think, to Robin's point, I think it's also really important to have at least one other thing going on so that you can have that as a backup. That's often what I would do upon reflection.
So I think we have time for kind of one more question that the group has provided, and then I want to save a moment to kind of ask the panel just kind of one last open-ended question. So the last one I'm going to kind of focus on here, and sorry that we weren't able to hit them all. But as you kind of look at the experience you had working with the RCD team, you were part of the supervisors, you had the mentors, what could they have done differently or in addition to what they've done to have contributed or supported you, going forward, through the career or at the circumstance you were in? Who would like to take this one?
I will go. So my professor while she was mentoring my research, had other 2 classes, so we weren't as involved as we wanted to. And I'm not saying like hopefully she gets one less class that way she can pay attention to me, but I guess just more meetings, in-person meetings with the students, the student and professors, but also that the meetings are really relevant to the research projects. So I guess like what's the next goal, have short-term goals and actually implement them by the deadline. Also, like what's a long-term goal for this research, maybe publish it for a conference, present it in a conference, a research paper, a poster, but have a goal set since the beginning, because sometimes a student might be invited into research, but he or she doesn't know what is going to be like the end goal. They may just do the work day to day, but then what is going to be next? Why am I doing this project? How is it going to contribute? So I guess the professor or the research mentor to have a specific set goal for the student.
Thanks.
In the meetings, yes.
Okay, thanks. Who else would like to tackle this one?
I also think that, at any opportunity, and Alper does do this. He was my supervisor at the time and my current supervisor, but more of this is great. Having students shadow anything at any opportunity. Like our team does a lot of individual meetings with researchers or research groups to understand their computational needs and, help them move forward. And I think especially just starting out as a student, it would be really beneficial to just kind of jump in the deep end there and get a sense of the types of questions that people ask in those types of meetings, the types of goals that people try to set. And I think from there, that's kind of a natural evolution for the student where they can kind of get that experience, and then they might kind of internalize some of the questions or things that are being discussed in those meetings, and they can apply that to their own projects or meetings with the supervisor themselves.
So maybe instead of trying to get a third for this one, I'd like to go to the last one because we are tight on time. So kind of as a final question, and I'd like to give all 4 of you an opportunity to answer this one. Are there aspects of your RCD part-time student experience that you'd like to call out, highlight, that the questions we've covered so far have not touched on? Something you think is important that we should be aware of? And how about we just go all the way around? Matt, if you wouldn't mind starting.
Yeah, happy to. I think honestly, the most important thing, and it is something that I think we've all kind of chatted about to various degrees, is just being, I guess, available for the students, within, I guess, a restricted time frame, like setting expectations, but being there as a source of support. You don't, I think, as a student, especially starting out something like this, especially if you're like me and you don't have a formal background in computer science coming into it, I think it is kind of an overwhelming field to just jump into. But having those mentors that are supportive and will, answer your questions, even if they seem kind of silly, letting you kind of, be present as the team does other types of work, I think for me, was the most valuable part of my experience.
Emerson.
I'll say this is a bit of a double-edged sword, but my experience, CHPC environments tend to be very slow moving. And while that can sometimes suck, that also presents an amazing opportunity where there's a whole world of exploration you can do, because like certain products or like certain things have not been adopted in that environment. Like as an example, like when I was looking at Ansible, I was looking at like Ansible and Puppet and Chef. Those were not being used at the CHPC at the time. And I think part of it is the CHPC tends to be a little slower, more conservative, like I think for good reason, you want to make sure that if you're going to adopt something, it's well worth it. But as a student, this presents an amazing opportunity where you have the world is your oyster in terms of being able to explore all these new shiny open source, I guess, quote unquote, open source tools that could maybe make the lives of the people at your workplace like better. And I think you should really, really take advantage of that, because at a lot of other places, like if you go into, like if you go work at like a larger tech company, those are already going to be decided. They're already going to tell you, hey, we use Ansible here, we use Puppet here, or Chef, whatever, right? And you don't get a lot of opportunity to actually explore the pros and cons and build up that knowledge for yourself. And so this is a really, I think this is one benefit I'd really stress to take advantage of, is the CHBC has a lot of the same needs that these other places do. It tends to be slow moving, for better or for worse, but that presents the amazing opportunity where you can explore as a student anything that you want. And you should really take advantage of that, because that will really expand kind of your knowledge and the way that you think about these sort of products and whatnot.
Great. Ira?
Yes. I guess I would like to highlight the importance of talking to the student, not only for technical and research based, but also in a personal way for the student, because as a part-time student and as a part-time job in research, the student may be completing 4 or 3 classes, depending on the graduate or undergrad, plus doing research, plus doing their own life. So I guess the importance of keeping that personal connection with the mentors. And I would highlight that in my experience, my mentor really did that. And also, I would like to highlight the importance to tell the students what are the opportunities for them outside, since they're doing the research or the research in computing part of their job. So what I'm saying is that if you are accomplishing this task within research, you can publish this, you can go to these conferences, you can get this internship, you can go into these fields. So because as students, we are not very aware of what is out there for us, and our mentors may have an idea of what is out there for us. So maybe sharing with that for the students will be really helpful.
Great. Thanks. Robin?
I think that my sort of takeaway here is very similar to a few things that have already been said, insofar as the mentorship is really the most important part of working at a high-performance computing environment. I would say that having high expectations from your mentor, but also having them be understanding that you are a student and you do have these other things that are taking up your time, that's really helpful, and probably not something that you would get at a job off campus or not associated with research computing.
Okay, thanks. Kind of pass things over to Anita and Betsy to kind of wrap us up. Thanks everybody for being patient for us going a little bit long.
Yes, and as well, I'd like to thank everyone. Anita, did you have any last final words?
No, I just really wanted to thank the students, ex-students, panel members. We really appreciate you taking the time to do this. It was a great conversation. Thank you.
Thank you, everyone. Take care.
Thanks, everybody.